Okay, Assalamualaikum and good afternoon. Okay, today we are going to do our net exercise 5.1.9. This is experiment for SPANY3 protocol. So what we are going to do today is just only investigate to observe how the SPANY3 work in our switch network. So in order to do this, you need to run 5.1.9 and follow all the instruction here. Nothing much for you to do, just to observe. Zoom. Okay, good. Okay, you see here we have a switch 1, switch 2, and switch 3 with a loop in here. But as you can see, dear LED, you see link between switch 3 and switch 2, the LED has been turned green. But a link between switch 3 and switch 1, one port has been turned into amber. So that means that port has been put in the blocking state, or we call them as an alternate state. Alternate port or non-designated port. But from here, can you say to me or can you guess which one is a root bridge? Okay. S2. Correct. Okay. Why we say S2? Because S3, of course, S3 cannot be a root bridge. There's a tip for you because it's a blocking state. Okay. Root bridge have all port changed into or put into designated state. Okay, so now we have S1 and S2. But is it S2 or S1? So how we are going to figure out which one has been put into a root bridge? You can only do guessing in this diagram only. If we have a bigger diagram, we are more switch, it's quite hard for us to do guess. I just asking for this diagram only. Okay, from the switch 2 and switch 1, you can see switch 1 have a connection to switch 3 with a blocking state. Actually, because we see the connection is using the same link, same speed. So of course, they need to have a root port connected to a root bridge. But if they are using a different speed, different link speed, it can be S1. So from here, you can say S2 because it has all port turned green, which is port connected to S2. From S3, G01, okay, green, and S1, G02 is green. So this port must be root port. Switch 1, switch 3, and switch 1 here are using a connection of fast Ethernet. So the situation might be changed. Okay, for you have some fast Ethernet, some gigabit Ethernet. So the root port will be chosen based on their cost. But now you can straight away compare how many link that you need to connect. Okay, never mind. So ping PC1 to PC2 should be success. Never mind, just do it. I'm doing ping. What is the IP address for the PC2? 192.168.1.101. Okay, so as expected, we get a reply. So what happened now? Actually, all the switch has been converged into a solid loop-free network, loop-free topology. So you should be able to get a ping. If they still in a problem with a redundant connection, as we discussed earlier, which is MAC address instability and so on. So PC1 might not be able to ping PC2. Okay, now we are going to observe SPANY3 on each switch. Use show SPANY3 VLAN 1. Okay, for your information, we are not creating any VLAN. So we are just using VLAN 1 for this network. Let's see on switch 1 first. Make sure you are in the exact privilege, enable, and then show SPANY3 VLAN 1. Okay. Actually, I can just show SPANY3. We show all. Let me show you without VLAN 1. Okay, it's okay. If you do show SPANY3, it will list all the SPANY3 that we have. But luckily, in this example, we only have VLAN 1. But if we have a multiple VLAN, we are using a Cisco device. We are not using the original, traditional SPANY3. We are using per VLAN SPANY3. That's why we need to provide the VLAN ID. But never mind, because our diagram are only using one VLAN, so you get the same result. Show SPANY3, you get one result like this, or you can do show SPANY3 VLAN 1. You get the same result. But if our device have multiple VLAN, you need to specify which one that you are looking for. Okay, good. Okay, now I show you how to read this output from the switch 1. So root ID, let's forget about root ID. Let's see the bridge ID first. This is the info regarding switch 1. Their priority value is a 32,769. Remember, the default value is a 32,768. And system ID extended is a 1. So the priority value will be 32,768 plus 1 because this is a VLAN 1. So if VLAN 10, it must be plus 10. So no problem. Okay. So we have our MAC address 00B, okay, BE31D3DA. So now it have the info on the top. Then root ID is a 32,769. Same priority value but different address 001 6448C6E7. So we know this switch is not a root bridge. So root bridge is from the other switch. We doesn't know which one now, but never mind. So cost from the switch to the root bridge is a 4, and you can see here our connection. This is actually a trunk connection that we have into a other switch, another port device. So you see G01/2 in a state or role designated port into G01/1. Sorry, G0/1. So you can see from the diagram is a connection to switch 3. Okay. So G0/2 role is a root. So it's a root port. G0/2 here, a root port connection to switch 1. And their priority number, this is the port priority number. So remember, if we have the same cost, we look for the bridge ID. So if you have the same bridge ID, which means you have two connections to the same bridge, same switch, we look for the port priority. Okay, port priority, we have the same here. It's a 1 to 8, and then we look for the port interface ID, which is G01. So this is the priority. So that's all for switch 1. So now take a look at switch 3. So I'm doing the same thing, enable and show spanning tree VLAN 1. Switch 3 has two connections, G01 and G02. G0/1, I mean G0/1, the role is a root. And G0/2, the role is a alternate. So as you can see from the diagram, G02, the LED has been turned into amber or orange. So that's verify our result here. This is an alternate. So let's take a look their output. Okay, bridge ID, priority 32,769. Of course, they are using a default value because we have done nothing. We do not change the priority value. And their MAC address is 000C. Remember our switch 1 here, 00B. And root ID, same priority with a different MAC address, 001. You see, from switch 1, the root ID, we use the same switch. Compare their MAC address 001/6448C6E7. Same from output from the switch 3. I'm sorry, as you can see here, even the switch name hasn't been changed. It's still stated as switch to show you that we have done nothing in this switch. We do not do any configuration. I can verify you by showing startup config. Not present. You can see. So this switch has just been turned on without any configuration. But they already select or they already build their own spanning tree or loop-free topology. Okay. Now, take a look at the switch 2. Enable, show spanning tree. Okay. Switch 2 has 3 connections. G0/1, G0/2 in the state of designated, and F0/1 also state of designated. F0/1 is a connection to a PC2. But as I said to you, all port on the root bridge will have their port turned into designated port. So it confirms what I said to you earlier. Okay. So let's take a look at their bridge ID. So bridge ID priority It's a default one, but their address 0001 and root ID 001. So it's the same bridge actually. So what happened now? Switch 2 is a root bridge. Okay. So that's how you read the output from there. So what else they want for us to observe? Okay, status, so you can fill out this result. I mean, not from this file, you cannot fill. Of course, you need to do somewhere. Okay, root bridge, is it switch 1 root bridge? No. We know it's a switch 2 is a, switch 2 is a root bridge. And you should know which one is in the forward, in the blocking. Okay, designator and root is a forward, and the alternate is a blocking state. I don't know why they put an alien sign here. There must be some symbol, but my computer cannot render it into a correct symbol, so you can see an alien sign here. I don't know how to read that. Okay, what path will friend take from PC1 to PC2? Even without looking or without using a simulation, you should know it must go from switch 1 to switch 2. Why? Because port G02 on switch 3 has been turned into a blocking port. But we can verify by using a simulation here. Let's do it again. Okay, I'm doing the ping. Sorry, I need to edit a filter first. Remove all and just pick for ICMP. So now we follow the data. Okay, so the frame has been sent to switch 1. Now from switch 1, I either need to go to switch 3 or switch 2. Let's see the addressing table. Show MAC address table. It's already clear the MAC address of PC2. Let's see what is the MAC address of PC2 here. MAC address of PC2 is 0060. So do we have 0060 here? It's not stated here. So it doesn't know. Why? Before that, I'm already pinged. Remember, I'm already pinged. They should already record, but when we have their age or their limit time exceed limit time, they will flash out. So that's why this sent to the switch 3. But you can see here, switch 3 will drop that packet. So which means blocking state will not accepting a data. So why switch 1 send? Because switch 1 doesn't know the state of switch 3. He just send. But switch 3 will block, will never receive. That's the point. Okay. So switch 2 are receiving the frame. And switch 2 are forwarding to all because it doesn't know the MAC address of PC2. But now, when PC2 receive, reply. Switch 2 doesn't need to send to all because switch 2 already have a MAC address of PC1 inside their MAC address table. If I show MAC address table, okay, PC1 actually their MAC address is 001. Okay, so you can see here 001. Which one? You have two 001. Sorry, PC1 is 001 C9B9. So let's see in here. C9B9. So it's connected into G0/1. So switch 2 we forward to G0/1, which is connected to switch 1. And switch 1 sent to the PC1. So let's see what happened to the second packet. Okay. Okay, now switch 1. It doesn't need to send to the switch 3 again. Because it's already know or it already record inside their MAC address table the MAC address of PC2. You can see before that there is no 0060. Okay, now we have a 0060. So switch 1 already know in order to reach PC2, we must go through G0/2. We don't care. It ada connector, ada device or no. But switch 1 know in order to reach 0060 must go out through G0/2. So let's go out through G0/2. Okay, the data flow out of G0/2 and arrive at the switch 2 at the G0/1. So now switch 2 are forwarding to PC2. So why do the frame not travel to switch 3? Of course, you can see for the first frame, switch 1 is sending to switch 3, but that in case of broadcast because switch 1 doesn't know the MAC address. But when they build the MAC address table, it doesn't need to send to switch 3. Even if they send to switch 3, the packet will be dropped. Why? Because G0/2 on switch 3 has been put in the blocking state or alternate port. Okay. Why does Penny3 place a port in the blocking state? Okay, because they would like to prevent a loop. So for the first time, remember, when the switch 1 doesn't know the MAC address of PC1, so they need to send to all. Okay, now observe Penny3 conversion. So for this part, I want you to play around, not only following what I'm showing to you. You can play around. Okay, even if you can, try to add your own switch. Try to build your own diagram, not only by using 5.1.9. If you add certain many free switch and you create the connection, multiple connection between switch, then we can have a better observation there. Okay, but follow me for this. Remove connection between switch 1 and switch 2. Okay, switch 1 and switch 2 here. Show spanning tree. Okay, spanning tree also work when we have a trunk. You can create a trunk later, but in this case, we are not creating a trunk. Okay, when we have a trunk, so one port has been turned into blocking, so the trunk will be turned off. Okay, this is on switch 1, you can see, and switch 2, I would like to show spanning tree. I want you to compare the result before and after. Okay, switch 3, show spanning tree. Okay, it's okay, done. So now we would like to remove a link between switch 1 and switch 2. Okay. Now, it's gonna take some time. Remember, they have the maximum time. But let's see on PC1 now. I'm going to ping PC2 straight away. Okay. I'm not going to turn into simulation. I just use a real time. You can see here, I cannot ping. Request timeout. Request timeout. They already sent 3 packets. Let's wait for the 4th packet. But as you can see from the diagram, G0/2 hasn't been changed to the accepting port yet. It's supposed to be a designated. So you can see here, switch 2 is a root bridge. So port on switch 2 is designated. Switch 3, this port will be root port. And now you can see, G02 has been, LED has been turned to green. Will be designated port, and G01 or switch 1 will be a root port. So let's try again. So now we can receive the reply. So they are using takeover. So the link has been takeover. So let's see the result on switch 1. So I'm sorry, they already pop up certain message here. So we cannot compare side by side, but never mind. I will scroll to you. So now, you still have the same root bridge, same bridge ID, but you can see they have a connection. G01 now is a root bridge, but before that, G01 is a designated, no, root bridge, sorry, not root bridge, root port. Okay, G01 before that is a designated port, and G02 is a root port. Now, G02 has been turned off, has been disabled, or have a problem. What problem? We remove the link. But in the real life, not necessary somebody remove the link. Whatever problem that block our data to be followed, then so that port or that link will be disabled. So we have open up another link. So you can see here, there is no G0/2 here. But G0/1 has taken over the root port. So that's the difference. From point of view, switch 3 is still the same. From point of view, switch 2 is still the same, except it doesn't have connection to the switch 1. Okay, finish with one explanation. Okay, now, observe spanning tree convergence. Quickly return to command line, show spanning tree, VLAN 1. Okay, so I did not do this, but you can see before that, there is a LED here doesn't change directly. So it's gonna take some time in order to convergence. Okay, remember we have the maximum lifetime, maximum age time, and in order to transition from one state to another state. Okay, maybe I would like to show you their status. Let me do again a connection between G02 and G01 in here. Okay, let's see here. I would like to show you Okay, sorry. Shows 23. Okay, G02 has been changed to the root port now. But it's state of listening. Okay, before that it's a forward and forward. But now it's state of listening. Forward and listening and sorry, not the stable 23. Now it's a forward. So it's gonna take some time before it change state from change status. Sorry, not state, status. Okay, let's take a look on the switch 3. Okay, status is the block. So let's remove again link between switch 1 and switch 3. I would like to show you on switch 3. So it's still alternate block. Still alternate block. Okay, it's gonna take some time. Okay, maximum age is a 20 second, forward delay 50 second, aging time 20 second. So from the alternate, they need to take 20 seconds from the last BPDU that they indicate this is supposed to be the alternate port. And then after 20 seconds, even though they already received another BPDU from switch 1, say G01 need to be a root, so this need to be open, but it's gonna wait until the aging time expire, okay? And then they are listening. It's not straight away to forwarding, and now they are forwarding. So you must wait for 50 seconds. So that's all that I can show you. So I want you to do all